Eulerian circuit means a circuit in which all vertices have even degree, right? So first we will draw the what graph. What is the graph? See, only 7 vertices are. V1 is connected with V3. This is first vertices. First is V1 is connected with V4, right? Sorry, V5. V2 is connected with V3. V2 is connected with V5. V3, V5. V3, V7. V4, V5. Where is V4? Let's suppose this is V4. V4, V7. V5, V6. V6, V7. So can you say this is an Eulerian circuit? No. Why? Yes. For Eulerian circuit, what condition is there? Every each vertices must have even degree, a degree even. So here V7 has degree 3 means odd degree. Yes, V5 even V5 has also degree 5 has also odd degree, right? You can write odd degree. So this is not an Eulerian circuit. Yes. Hmm. Okay. Notice. For only circuit is there. Then very good question. If G is a simple graph with n vertices, what is the maximum number of edges in graph? Justify your answer. See, maximum number of edges will be what? incomplete graph, right? If what is simple graph? Simple graph means a graph in which there is no loop, no self loop, and no multiple edges. So you can see here number of vertices is 3. The number of edges will be 3. If you connect all vertices, here number of vertices is 4. Number of edges will be 6, right? How? See, 1, 2, 3, 4, 5, and 1 is 6. Other side, this side. No, no. This is same as this, right? You can connect in this way or in this way. Understood? If you connect like this, it becomes a parallel edges. And in simple graph, there is no parallel edges, right? So when you see n is equal to 5, number of edges will be 10, and so on. So if G is a simple graph with vertices n, with n vertices, then maximum number of edges is equal to n minus 1 by 2. Okay, you can check. Put here 3, you will get 3. Put here 4, put here 5, right? Yes. And how will you justify? By giving example. So first write this theorem and give example. Okay. Now see this. Using flat algorithm, find the shortest distance between any pair of. Okay. Yes. We have not covered what? Flat algorithm, right? So how will you cover? How will you? First, I will tell you. Yes. So we can do it later or right now. Okay. I think this topic will come in next topic next time. Okay, because there was no flood algorithm in your PDF. What? Okay, next session. Uh, Whether this graph is isomorphic or not. So what is the condition of isomorphic? Yes. First count the number of vertices. How many vertices are there? 4 plus 4. 8? 8. How many number of edges? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? And here 4, 4, 4, 8, 8 and 4, 12, right? Yes. So first, yes, first draw the adjacency matrix for both graphs and check whether they are same or not. Try this. Yes, here you can see what? See, the degree of each vertices is what? 3. And in this graph, the degree of each vertices is 3. Okay? Degree sequence are same. If degree sequence are yes, then if the degree of each vertices are 3 in both graph, then they are adjacency because each graph is connected with that vertex whose degree is 3, right? Yes. Adjacency preserve. How will you write this? You have to do only what? Write adjacency matrix and write what? Number of edges and number of vertices are same. This is first condition. Second condition is what? Degree sequence are same. Okay. Third is what? If so, find an isomorphism. Isomorphism means you have to write the all properties of isomorphic. Okay. So these you are writing. No, no, no. Don't draw because this is already given. Just do only one thing. What? Find adjacency matrix. For both graph. Sec for both graph. Equal. They are adjacency. Okay. Yes. Done. Done. Adjacency preserve means each vertex has degree 3. Nothing to write. That's it. No need to write anything. Okay. Yes, if you are getting same value, they are isomorphic. So we have not done disaster yet. So we will see next time. See, Is there any simple graph with five vertices? Right? Think about it. Yes, their degree sequence are 1, 1, 2, 4, 4. Give me 1 minute, one call is coming. Draw a simple graph whose degree sequence are 1, 1, 2, 4, 4. So, very simple, it's very easy. What will you do? First, check which vertex at degree maximum? 4, 4. So, there are 5 vertices, right? So, one vertex is at degree 4. This is connected with all vertex. Yes. One has, let's suppose this vertex has also degree 4. 2, 3, 4. Right? But here you can see what? Two vertices at degree 4. This and this. But you can see one thing, what? One vertex, only one vertex is at degree 2. Here two vertices at degree 2, right? Three vertices at degree 3, 2, which is not possible. And two vertices at degree 1, 1. This is also not possible, right? Na? So not possible. Yes, you can prove by using handshaking theorem. Sum of sum of degree will be, so number of edges will be 6. So can you draw a graph with 6 vertices and 5 vertices? 5 vertices with 6 edges is not possible with degree 4, 4, 2, 1. Okay. Yes, that is for maximum number of edges. That, yes, yes. See, uh, uh, minimum age will required will be 6, right? But here you can see for 5 vertices, for 5 vertices, yes, 7 edges are there. Still no, it is not satisfied because you are not getting degree 1, 1 vertices, right? See, I tell you how to write properly. Uh, the maximum degree of vertex is 4, right? Two vertices has degree 4, 4, right? Let's suppose these are two vertices. Okay. And let's suppose this is second vertex, 2, 3, and this is 4. Now you can observe that there are two vertices with degree are 2, right? Okay. First of all, I tell you this is called Havel Hakimi method. This method is used for checking whether the graph exists or not, a simple graph exists or not. So first of all, write the degree sequence in descending order. Okay. This vertex connected four other vertex, right? You understood? First, first vertex is connected with next four vertex, right? It means when you delete this vertex, right? Let's suppose this vertex. When you delete this, all degree of all vertices are subtracted by 1, right? It becomes what? 1, 0, 0. Understood? Because when you delete this, the degree of remaining vertex will be what? 1 less than the original matrix, right? Huh? Hey, yes, 3, 3, 1, 0, 0. Right? Actually, you did what? Y- No, no, no. No. You see, when you delete this, delete means what? When you remove first four, you remove what? First four. You will get what? One is subtracted. Understood? Now you can see what? When you delete this, it means one degree of each remaining vertices will be less than the original vertex. When you remove this, you will get what? 0, -1, -1. And this is not possible. The degree of any vertex is negative is not possible. Understood? So whenever you get negative, it means they are not valid. It means no simple graph exists. Understood? I explain with some more example. First write this. Hello? Screen visual. There are some questions. These are some questions we will practice. Okay. Now see first question. How many vertices are there? Okay. So it is already given in descending order. First thing, right? So there are total 10 vertices, whose maximum degree is 5. Okay. So when you remove first vertices which are connected with 5 other vertices. 5 other vertices means what? When you remove this, 5 other remaining vertices are subtracted by 1. Right? Only take a color. So remaining 5 vertices are subtracted by 1. It becomes 2, 2, 2, 2, 1. Right? चलो ठीक है परसों आ जाए. Understood? Now again arrange this into descending order. When you remove this, only 2 remaining adjacent vertices are subtracted by 1, 1. So it becomes what? 1, 1. Other will be same, right? Again arrange this into descending order. Okay. Last element was this one. Yes, yes, yes. 2, 2, 2, 2. This one. No, this vertex is connected with these two vertices. When you remove this, one is subtracted from these two only. Okay. Yes. Second, no, after this, you are going to arrange in descending order. One extra two. So here 6 two. Yes. So when you again arrange, when you delete this, what you are deleting this? 1, 1 is subtracted. Again, arrange in descending order. Understood? 6 ones are there. When you delete this, 1, 1 becomes 0, 0. Right? Yes. 0, 0. When you delete this, it becomes 0. Right? Again, arrange in descending order. When you delete this, you will get what? 0, sorry, 1, 0, 0. All zeros are there. So it means, yes, this graph can be exist. Okay, and you can draw the graph. I show you how to draw. First, see. If this exists, then you can confidently draw the graph. Let's suppose this is first point. Okay. No need to write. I will give one question. See, first vertex is at degree 5. So let's suppose this is 5 branch. Understood? Second have degree 3. Degree 3 means already one is there. 2 and 3, right? The third one has degree 3. This is connected with 2 and degree 3. The third one is also connected with degree 3. Already degree 3, right? Yes. Now this is what? 3, 3, 3, 5. One degree is, one vertex is more there, whose degree is 3. So let's suppose this is connected with this. Okay. Its degree is 3. Its degree is 2. Its degree is 2, right? 2, 2. Its degree 2, right? Degree 2, 1, 2, 3, 4, right? You can see 1, 2, 3, or you can write A, B, C, D. A, B, C, D, E, F, G, H, I, J. Okay. I think I took extra vertices. Okay. You can count. There are 10 vertices. Its degree is 5. Its degree is 3, 3, 3, 3. This is 2, 2, 2, 2, right? And its degree is 1. Which satisfied all properties. And how Havel Academy theorem works? When you delete this, all remaining vertices are subtracted by 1, right? When you delete 5, its degree was 3, but now it becomes 2, right? This also becomes 2, 2, 2, because when you delete this, other remaining 5 vertices are subtracted by 1. Understood? Yes. And degree 2 is also becomes 1. And the remaining will be what? 2, 2, 2, 1. Yes. First of all, arrange into descending order. So I think there are 7 twos and 2 ones. Why? Because when you deleted vertex A, you have remaining what? Right? B, C, D. Okay. This graph will remain. Okay. Yes. When you delete this, only two remaining two vertices will be disconnected. Understood? Yes. You want to write this? Do one question. This one. Okay. So according to you, graph will be exist, right? Okay. Sir, first count how many number of vertices? 7, right? Okay. So first vertex is connected with 6 remaining vertices. 1, 2, 3, 4, 5, 6, 7. Sorry, 6, right? Okay. Second vertex is connected with 5 remaining vertices. 1, 2, 3. Its degree is 5, right? Okay. Its degree is also 5. 1, 2, sorry, 4. And one is connected with 5 vertices. Right? Okay. One vertex is a degree 4. Its degree is 4 and its degree is 3. And one is 2. Okay. But graph is not possible, right? Uh, when you cut 6, you will get what? 4, 4, 3, 2, 1, 0. Right. Okay. When you cut 4, you will get what? 3, 2, 1, 0, 0. Oh, this is the graph will not exist. Why? Because when you cut 3, remaining adjacent will be 1, 0, minus 1. Is it possible? Yes. Not possible. Understood? Yes. That's why it is not drawing. Draw a graph which is neither Eulerian circuit nor Hamiltonian circuit. So this type of question you have to learn. Okay. Learn one example of what? That is Euler but not Hamiltonian. That is Hamiltonian but not Euler. That is both and that is both not. Okay. I show you. See this. This graph, learn this graph. Okay. Yes. I explain this. First graph is Eulerian and Hamiltonian both because you start from this point and end with this point, covering all vertices and edges. This means this is Eulerian and Hamiltonian, right? Okay. This graph is Hamiltonian but not Eulerian. Why? Because when you start from point A, you cannot return to point A, covering all edges. You can try, you can do this. And I already told you the degree of each vertices is not even. This is not Eulerian but Hamiltonian. Okay. And thus this graph is Eulerian. This is Eulerian because each degree is even, but not Hamiltonian because this vertex will be repeated, right? Eulerian but not Hamiltonian. And this is both neither Eulerian nor Hamiltonian. Okay. So you have to learn this graph anyhow. Always remember one example. Okay. We have not done disaster algorithm yet, right? Chromatic number. We have done chromatic number. Okay. Flat algorithm not done. Okay, I tell you this. Does there exist a three regular graph with 109 edges? Which one? No, no. Does there exist three regular graph? Regular graph means whose degree is same with yes with 109 edges. Let's see how many number of edges are there. Three regular graph means what? I already told you what is regular graph. Yes, each vertices have degree 3. Okay. If two regular graph is there, then you can say each vertex has degree 2. Right? So, but you don't know how many vertices are there. Right? Let's see. The sum of degree is equal to 2 times number of edges. This is what? And second theorem. Okay. Now 2 number of edges is what? 218, right? Yes. But you don't know how many number of vertices. Okay. Each vertices at degree 3. Let's suppose first vertices at degree 3, second vertices at degree 3, and so on. And you don't know how many vertices. Let's suppose this is n vertices. Okay. N times. No, no, no. 3 into n. Because when you add 2 to 10 times, it becomes what? 2 into n, na? Yes. What? Find the value of n. Yes. 666. Which is not possible. Number of vertices cannot be fraction, right? Yes. Since number of vertices cannot be fractional, so graph does not exist. No such graph exists, right? Does not exist. Is K5 is an Eulerian circuit? K5 means what? A graph, complete graph of 5 vertices, right? Okay.